Hi everyone, my name is Tala and I'll be starting our presentation by introducing our project and the problem we're trying to solve. One of the major issues in healthcare today is medication non-adherence, which simply means people forgetting or not taking their medication on time. This might sound simple, but it actually leads to serious health risks, hospital visits, and complications, especially for elderly individuals, people with disabilities, and those with chronic illnesses. Many patients rely on daily medication schedules, but it's easy to forget doses, especially when someone has multiple prescriptions. Missed medication can reduce treatment effectiveness, delay recovery, and even cause long-term medical issues. That's where Pillsync comes in. Our goal is to create a smart, automated pill dispensing system that not only reminds the user when it's time to take the medication, but also dispenses it automatically, tracks whether it was taken, and can notify family members or caregivers if needed. The idea behind Pillsync is to make medication management simple, reliable, and accessible. Instead of manually counting pills or relying on memory, the device provides reminders, keeps timing consistent, and helps improve overall adherence. By addressing this problem, we hope to increase medication reliability, reduce stress for patients and caregivers, and support independent living for individuals who may struggle with remembering their doses. With that foundation, I'll now pass it to the next part of our presentation, where my teammate will walk through how the system works and the engineering behind it. Thank you.
Thank you, Tala. Next, we will look at the system flow and device function. Here you can see how the entire process operates as a closed loop. The user enters their medication schedule, the device tracks those times, and when a dose is due, Pillsync triggers a timely alert. From there, the fingerprint verified dispense process confirms the correct user and releases the medication. Overall, the goal is to keep the system simple, reliable, and supportive of a consistent daily routine. This clip provides a quick walkthrough of the Pillsync user interface. When the system loads, the user is greeted with a simple login screen designed for fast, secure access. After signing in, the dashboard presents a clean overview of upcoming medications, stored user profiles, and overall system status. From here, users can navigate to the prescription management page, where new medications can be added using straightforward fields for dosage, frequency, and refill times. Every entry is logged into the database, ensuring schedules remain accurate even after power cycles. The interface also provides access to the alert system. When a scheduled dose approaches, Pillsync automatically triggers both visual and audio notifications, keeping users on track. On the dashboard, the manual dispense button allows the user to trigger a dose when needed. The system routes this action through the fingerprint verification before dispensing, adding a layer of safety and accountability. Overall, this UI aims to stay clear, responsive, and easy to navigate, making daily medication routines more organized and reducing the chances of missed doses. To wrap up the design and functionality, the goal behind Pillsync is to keep the system simple, secure, and reliable. All data is stored locally on the device to protect user information, and dispensing can be done through the web interface or touchscreen, depending on the user's preference. By keeping everything inside a closed system loop, we maintain consistency and ensure the device performs the same way every time. Overall, the design focuses on delivering a user-friendly experience while maintaining dependable operation.
The main theory of Pillsync is to prevent non-adherence by minimizing user errors, reducing the effort the user has to make, and adding safety barriers that guide them towards the correct dose at the correct time. The user or caretaker sets their medication schedule through the interface, and the system uses time scheduling to control when the dose becomes available. This helps prevent missed doses, but it also prevents the users from taking a dose too early or accidentally taking more than they're supposed to. Next, we use pre-sorted containers. These containers are organized by day and time, which makes the system easy to use while also supporting multiple users if needed. This removes a lot of confusion that normally happens when someone manages several medications. Biometric authentication adds another safety barrier. The fingerprint scanner verifies who is retrieving the medication before the system unlocks, preventing unauthorized access or someone accidentally taking another person's dose. Finally, alerts and notifications help the user stay on track. Pillsync uses a combination of SMS text messages, sound alerts, and visual indicators on the device. This gives the users multiple reminders so they know exactly when a dose is due and can quickly see if one was missed. So overall, each part of the system works together to reinforce our main goal: reducing errors, keeping medication secure, and guiding users towards safe and consistent adherence.
As for the results and testing processes, there were a lot of prototyping, such as multiple casing revisions, as well as multiple internal gear revisions. There was a continuous reworking of the design. There were lots and lots of prototyping with the code to get it fully functioning on the device. And the results were that we finally have a fully 3D printed shell that's custom made, a functioning display and the code to go with it. It is currently working mechanically, as well as a sorting piece that would funnel down the pieces to the pill holder. And then finally, there's a modular design for replacing parts, so that if a part breaks, it can be replaced with just some friction, and so that it's very easy. And then as finally, there's an open back to show the functionality, such as the gears, the Raspberry Pi, the IC2 boards, and the such, as well as for ease of access. But this is also just to show how it works, so that it can be seen how it functionally uses the parts to come together. And this will not be for the final product, but it will be it will be what we use for the showcase, just to demonstrate the prototype.
To wrap up, Pillsync is designed to help reduce missed or forgotten doses and make it easier for people to stay on their medication routine, whether that involves a single daily pill or multiple medications throughout the day. The system runs on a Raspberry Pi, which handles fingerprint authentication, the scheduling logic, a simple on-device touchscreen interface, a local web interface that can be accessed from a browser, and the control logic for the dispensing mechanism. The system design combines biometrics, automated dispensing, and SMS alerts into a single pill management setup so that users can be identified and reminded when a dose is due through both on-device and text message notifications. Using more than one notification channel adds flexibility and makes it harder for a reminder to be missed. Looking ahead, future work could focus on fine-tuning the dispensing mechanism and adding sensors to verify that a pill has been released during each dispense cycle. There's also room to improve the dispenser and enclosure so it is easier to place, use, and refill in a typical home environment. Additional future directions include a potential dedicated mobile app for remote access and notifications, building on the existing local browser-based interface to better support caregivers and everyday use.